Welcome to the Beginner's Revit course, where you will learn Revit in the easiest, fastest, and most enjoyable way possible. My name's Kyle and I'm a master's student currently studying architecture here in South Australia, and I'm also working at a commercial and residential practice at the same time, and all we use is Revit. Revit is the leading software in the industry, and if you want to work on architectural projects, you'll need to learn Revit. And in this 9-part course, you'll learn it the right way. You're going to learn Revit from scratch by modeling up a 3-story residential project. This course will give you the skills and confidence you need to be able to model up and design in Revit. This course is being released here on YouTube over the next 2 weeks. Otherwise, if you'd like to watch it all ad-free right now in a highly curated platform, you can head over to my website where you'll also find all of the project files and materials for the course. To access that, you can just click the link in the description below that will take you to my website, and I'll see you there. So yes, what we are designing is a large residential property. In fact, this is my old house. If you wanted to, you could do this with your own house. You could do this with an old house of yours or a building that you really wanted to model up. If you want, you can just follow along by following the exact same procedure I do for my old house. Otherwise, I have all of the files available for my old house on my website. So if you want, you can just follow along with me. And that is the easiest and most efficient way to learn new things, by actually doing it. So let's open up Revit. I'm using Revit 2020. If this is your first time opening up Revit, we're going to go through everything real nice and slowly so that we can learn Revit for beginners. As you can see, apparently I don't have a license, but I do, so we're just going to run it. If you're a student like me, you do not need to pay for Revit. It is absolutely free with a student license. You just have to prove that you are a part of a educational institute, and that is really helpful because Revit costs a fuck ton of money. Anyways, here we are. Look at this starting screen of Revit. How daunting is this? How exciting is this? Both of the above. What you've got here, you've got models and families. Models and families. What's the difference between the two? Models, these are your projects. So this is the project that you are opening. Say you're in SketchUp. I'm guessing a lot of you have used SketchUp if you're now moving into Revit. SketchUp, you've got your project, which has the model in it. That is just everything in the model. A family, on the other hand, is an individually designed part of your project. That might get a bit confusing, but as you can see, the sample architecture project here, it's going to be your whole model. It's got everything in it. But then the families, you can see there's a screw. There is a table. There are trusses and some other systems and stuff like that. These are individual components that go into the model. It'll make sense once we get into it, trust me. So then obviously we're going to be starting a new project, in other words, a new model. So we're going to hit new, creates a new project. Now, we have to choose a template. We are architects, we're going to choose the architectural template. Otherwise, if you're working in a proper practice, often they'll have their own templates set up that you can just open up, and it will have everything preloaded in it, all of their families and all of their title blocks and project information, that kind of stuff, preloaded, and it makes life a lot easier. But in this case, if you're using this for a student project, architectural template, completely fine. But then obviously if you want to make your own template, you can do that by clicking there. We're not going to do that. We're going to keep this nice and simple. Let's open up a project. This is scary, isn't it? Revit. It's not that scary, trust me. It looks like there's a lot going on. There's not. This is really, really easy. Take a deep breath. We're going to get through this. Let's just go over some of the things that are happening right now on this screen. So you can see you've got your workspace. This is your model workspace. Just like AutoCAD, just like SketchUp, you're probably familiar with this stuff if you are an architecture student. So you've got your workspace, and that is where you're going to do your work. Then you have your toolbar. This is this ribbon up the top. And as you can see, there's an architecture tab. And underneath the architecture tab, there's a whole lot of other tabs. You've got build, you've got circulation, you've got model, and all these other things. This is where you'll do most of your architectural stuff. This is where you're adding in walls, adding in doors, columns, roofs, all that kind of stuff. And you might be thinking, why don't we just draw up a mass of our project? Revit is different. Revit is a BIM software, meaning it's a building information modeling software. Essentially what that means is that as you model up a project, you're modeling up something that is representing something in real life. So your model is a scaled down version of a real life project, a real life building that can be built from this model. Whereas in SketchUp, you're just pulling up masses and you're just playing around with the geometry of things. Revit is very much, you've got walls, you've got floors, you've got ceilings, and you've got wall thicknesses with things inside the walls. So you'll have a stud, you'll have an outer face and an inner face. All this kind of stuff seems really daunting. It's not, trust me, you'll see from this course. And so that's why you've got all these different components underneath the architecture tab. For structure, you're probably not going to touch any of this. You're an architect. This is going to be for, the structural engineers, the civil engineers, that kind of stuff. Whereas you might touch on some of these things every now and then. You might use a grid. You might need the reference plane, which is also under the architecture tab. So is the grid. You're probably never going to use this unless you're doing a little bit of structure yourself. Steel, never use this myself. As an architecture student, you probably don't need to touch this, so we're going to skip over it. Systems, obviously, that's for systems. If you're a mechanical engineer, if you're a service consultant or something like that, this is what you're going to be using. I've used this for one project in architecture school, and that was very basic, adding in some ducts, some terminals, and some pipes and electrical stuff. You're probably not going to use it. And when you do, you'll figure it out. Let's just skip over that. The insert tab, this is what we need, right? So we want to add the floor plan to our workspace. So you're going to go to the insert tab to insert stuff. That makes sense, right? I hope it does, but we'll come back to this, okay? Let's just keep going. And then you can kind of guess what the rest of these do. If you're annotating something, you're going to go to the annotate tab. If you need to analyze something, you're going to go to the Analyze tab. Again, I hardly ever use this. The main ones you're going to need is the Architecture tab, the Insert and Annotate tab, Massing and Site. You might need the Manage tab. This is just to manage your project. There's not much apart from changing properties and stuff like that in here. And then most of these other ones are from plugins, which you might not see. So really, that's pretty simple. There's 3 or 4 tabs you need to know about. Now you've got the properties panel to the left here. This is where you change properties of the individual things you have selected. At the moment, I have nothing selected, so it's got the properties open for the ground floor plan, which is what we're looking at here. And you might be thinking, why is this a ground floor plan? I just want my 3D view or something. And that's when you go down to the project browser. This is where you can look at your floor plans, your elevations, your ceiling plans, your sections, and then you've got all your families, legends, schedules, all of that stuff is in the project browser. And the reason why you've got these different views already set up is because we use that architectural template when we set up the project. I'm going to just place a wall in the middle of my site here. I clicked on the wall button. Yep. I clicked on the wall button in the architecture tab, and now I can draw a wall in my project. I'm going to hit escape there to get out of that, hit it again so that I'm no longer creating walls, and that's a floor plan view of a wall. But if we go into the east elevation, you can see it there in the project browser. If we double click that, now you've got this wall we've just created. Wowza. If we go back to the ground floor plan up the top here, this tab, this brings us back to the ground floor. So it's not creating a new view, it's not changing anything. You're now just opening up these views. If I open the north elevation, that's the wall in a north elevation view. And as you can see, it brings it up to the top here. You've got the east elevation, you've got the ground floor plan. These are all the views that we've opened. Let's say I wanted to get out of these elevations. If I click the X's, oh no, now it's gone. Or is it? In fact, it's not gone. You haven't deleted that wall. What you've done is you've just closed that view, which is now available to access again in the project browser by double clicking in the project browser. And so these are just opening up the views. Closing them is not going to delete any of your items that you've modeled up. It's a really smart way of modeling because you model something in one view, in your ground floor plan, for example, and it shows up in every single other view. Every change you make to this wall in the ground floor plan, it changes it in the elevations and vice versa. As you've been modeling up your building, you have also been drawing your elevations, your sections, your floor plans, your details, everything you can think of in an architectural documentation set. Every change you make in the elevations to this wall, let's say we go into the east elevation and we bring this wall in to 14,000, right? You can see the dimensions there, from there to there, that's 14,000 millimeters that would probably be. If we go back to the ground floor plan, that wall just got shorter and now that is 14,000 millimeters. Pretty smart stuff. So if we go into a 3D view with this button up the top here, otherwise you can go to the view tab and you can click on the 3D view button here. That will bring up a 3D view of our wall. So this is the model space. You can see what I'm doing here is I'm holding shift while using the middle scroll wheel and that rotates around this wall. Otherwise, if I just hold the middle scroll button, that is just going to pan across the screen. And if I click on an object and I hold shift and I hold that middle scroll wheel, I can now rotate around that specific object. So that's pretty cool. Again, any changes I make to this wall in the 3D view, that's going to show up in the elevations as well. As you can see, that's just moved that out. And the ground floor plan, it's now rotated around. BIM technology is very smart, and that's what Revit is. It's very smart, but there's also a lot of problems that come with that, which we will kind of find out in the near future. So you just got to be careful that when you're changing something in one view, it's actually changing it across your whole project in all of the different other views. You can also access your elevation views with these elevation markers here. That there is an elevation marker. If I put my mouse over it, you can see that it's an elevation. If I click on that, this is just the marker. That is not going to move where the elevation actually is. If I click on this little arrow bit here, you can see that that is where the elevation actually goes. At the moment, all you need to know is that up the top here, this ribbon, that is where you're going to be doing most of your work. That is your tool set, I guess. That is your toolbox of things that you can use for your project. But then when you get to the properties panel, which is this section here, which actually you can drag off of the project browser, so that's a bit more clear. What I'll usually do is put this in the project browser on my next monitor so that I've just got a big workspace, but let's not do that so we can actually see what's going on. The properties panel here, this is all of the properties of whatever you have selected. At the moment, there's nothing selected, so it's the view properties, which is the floor plan properties. If I were to select this wall, you can now change the properties of the wall. And you can see that at the moment, it's a basic wall, which is double brick and 270 millimeters in thickness. This is also where you change the heights and the thickness and where the wall sits, things like that. As you can see, the base constraint is currently on the ground floor. How do we know where the ground floor is? If we go to our east elevation view or any of the elevation views, you can see that there is a level set up with the ground floor. With using the architectural template, this is already set up for us and the ground floor is at 0. But for example, as we will get into, if the ground floor is not directly on 0, you'll usually be given a survey drawing, giving you the contours of a site. If you're doing this for a project, you can adjust this according to that. But in this case, the ground floor is on 0. And this wall is sitting on the ground floor for the base constraint. If you were to offset that by say 200 millimeters, that is now going to be 200 millimeters above the ground floor. As you can see, we can use the measure tool here, measure between two references, and we can just measure this and it will be 200 millimeters difference. If we bring up the properties again to the left here for that wall, you can obviously then change the top constraint. At the moment, it's not connected to any levels. But if we wanted to connect it to the first level, which is 4,000 millimeters above the ground floor, we can click on this little arrow here. If you can't see that, whoops, we're just going to, you can click anywhere on there and then click the arrow. And then we're going to say up to level 1. As you can see, that just brings up the wall up to level 1. It is now 200 millimeters above the ground floor, and it goes up to level 1 for the top constraint. Otherwise, we can adjust that without constraining it to a level by going unconnected and then changing this to, let's say, 6,000. And as you can see, there's an apply button down the bottom. Or what you can do is move your mouse off of the properties panel onto the workspace and it automatically applies it for you. Next up, you've got structural stuff. Never going to touch that. Dimensions. This is where you can find your lengths and areas, stuff like that. Not super useful. Don't touch identity data. So if we just minimize all that, you can see there is phasing. And this will definitely be new to you and it might seem a bit scary, but it's not, just like any of this. What phasing is setting up your document to be in different phases, right? For example, the phase this wall was created in new construction. If we click on the arrow, you can see that there are two phases for phase created. There is existing and there is new construction. The difference between these is that when you're modeling up an existing building, you would make this existing. This was created in the existing phase. If we're working on a project that has an existing building and you're doing an extension to it, you would create all of the existing stuff using this existing phase, and you can change this after you create your object. If you were to then start doing additions to the building, you would put this under new construction. But let's say then you wanted to demolish something in your building to create a demolition plan. The phase demolished would have been in new construction. So really you've got two phases. You've got existing and new construction. All of the existing stuff that happens before you've done any work to the design, that stuff goes under the existing phase. Any changes you make to an existing building, whether it be you demolish it or you're adding on new stuff, you would do that under the new construction phase. And these are set up in this template, but some practices would have different phases set up, and we're not going to get into that because that can get really complex and stupid. But in this case, you've got two phases. And this is all you need to know for the moment, as we're going to get into it soon and you will see exactly what this means. I just thought I'd introduce you to it. You know what, let's actually go through some of the photos of this house so that you know what this looks like and what we can expect to be modeling up. I have some photos for you. This here is my old house. It's brick. It's built in the the mid-90s. Not the mid-90s, the mid-1900s, so like 1950, 60. It was a pretty luxurious house. It was 3 stories. It had a nice big garden out the back. This is the front here. You had the big driveway which went around the entire house and a nice garden there as well. Going on to the next photo, we have the kitchen, nicely renovated just before we left and we never really got to use it. Nice big island bench and splashback, large windows out into the, I guess the, what's the word I'm looking for here? The scenery in the backyard. That's not the word I was looking for, but that kind of makes sense. This was the large mirror we had at the front entrance. This is the front entrance here. If we look at the floor plan, you can see that the front entrance is down here. So this was the front of the house, and this is where the driveway ran around, and this is where the garden was, and then the front entry is right here. And that's what we're looking at. That's the garden and that's the driveway. You come through and you enter here. Then we go to the next, wait, no, we're going the wrong way. Then we've got the games room. This was fun. Oh, fuck. I remember running through that sliding door as like a 7-year-old and I had blood all over my face. And yeah, it was actually my brother's birthday or something. And I was just hyped up off sugar, like some crazy kid who's 7 years old. And I remember someone saying, let's go on the trampoline. And so I sprinted through the closed sliding door and I, split my head open and I made a fool of myself and I started crying like a little bitch. That was fun. Lots of good memories there. This is the backyard. This is the big pool and the balcony we had. I remember sprinting down here in summer and it was like timber steps and they would get really fucking hot, like 80 degrees scorching, and I'd burn my feet running down there and then I'd jump straight into the pool. Always good fun. Anyways, let's just skip through the rest of these. There's going to be baby photos of us around the place, so do not even worry about them. This is the downstairs bathroom. This is looking out at the backyard. Huge backyard. Really miss this. We left over almost 10 years ago, so I'm not that sentimental about it, but it was a really nice house and we were very lucky to live there. Big ass backyard. Used to play ice hockey out there, like ground hockey, but yeah, practice my ice hockey. a nice fireplace and some two little doors we used to break into to get inside the house. That was actually on the balcony, and we would forget our keys after school and we would just break through these little mini hobbit doors, we called them. Yep, that's nice. Kitchen, living space. I remember playing Monopoly there. And that's the front entrance again. That's the main road. And you'd enter in through there. So this is what we are designing up, boys and girls. We're going to model up this house. And there you have it. That's not me, that's my brother. Let's not look at that. It's always good to know what you're modeling before you model it. And now we can get into modeling up this building. I'm going to delete that wall. We're going to go to the ground floor plan view. The reason why we're going to do that is because now we're going to insert the ground floor plan from the real estate website. I'm going to click the insert tab up the top here in the ribbon. And we're going to go to, what do you think? Tick, 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 tick. What do you think we're going to click? We're inserting an image. So click that button. Now we're going to go find where this is. So if you've downloaded this, go and find it. Go follow along with me. If not, you can watch. That's okay. We're just going to left click to place this. And this is the floor plan. It's a bit blurry because the resolution is shit, but that's okay because we can see everything we need. But the first thing we need to do is make sure that this is to the right scale. How do we know that? Well, as you can see, the real estate people have nicely given us some of the dimensions that we need. And that would be, these areas here, 3.9 by 6.8. So let's find a nice and easy one. 4 by 2.4. Let's press this measure button up here, which is the same measure tool we used before, but it's just a smaller icon because this is something you use quite often. I'm going to click on that and I'm going to measure from the inside of the wall to here. And as you can see, that's about 15,000 millimeters. So it's about 15 meters. That is not 4 meters and that is not 2.4 meters. And looking at the dimensions of this, we can tell that the long side is this side here. So this is going to be 4 meters and the short side is going to be 2.4 meters. And so if that's 15,000 millimeters or 15 meters, and it's meant to be 4 meters, the scale is obviously wrong. To change that, what we're going to do is click on this image and we're going to click the scale button, which is actually up here in the modify tab. And this is only going to come up once you select an item. So I clicked escape to unselect the image and clicking on it, this brings up this modify tab, which you did not see before, but this is a new tab. Again, not scary. What we're going to do is click on the scale tool. Otherwise you can click RE to scale. We're going to click on one corner that we want to scale from to the other corner. And we're going to make it 15,000 to make it easy. And now what we're doing is we're choosing how big we want this image to be according to that reference we just made. And because we know that's meant to be 4,000, but it's actually 15,000, we can drag this down to be 4,000. Otherwise, what we can do is type in 4,000 and this is going to scale that down to 4,000. Let's actually get another measurement. You can click up here or you can click on the measure button, which comes up in the modify tab when you select an object. And we're going to click that measure button and let's make sure that this is actually now 4 meters. So we're going to go from one side to the other. And that is pretty close to 4 meters. And so now we have a 2-scale reference image that we can use to start modeling up this design. There is something we should do first. We should put in a topography for the site. But I think we're going to come back to this. Let's put in some floors because that's the fun part. Let's get in the floors of this building. The first thing we want to do is make sure our levels are set up. This is how you're going to do it in a practice. If the levels aren't set up, you're going to fuck yourself over and you're going to fuck everybody else over by not putting in levels correctly. And this happened in the residential firm I'm working for. There was another student who made some changes to the levels I set up and threw everything out of proportion because, if you have... Remember how we had that wall set up and it was constrained to level 1? If all of your walls are constrained to level 1 and you move this to 10,300, all of the walls get thrown up to this height. And whereas it's an easy change to just throw this back down to 4,000, there was a lot of these changes which made a lot of problems. We know about levels, how important they are. Let's start creating some for this project. I'm just going to drag this out using that little circle button, and you can lock it onto the other one and it looks really neat. So keep that in mind. You want your project to always look neat. All right, so the ground floor is at 0. Now we need to know how tall the first level is going to be. As you know, this is a 3-story building. There are 3 levels, and so we need to set up these levels before we start modeling anything. We're going to look at the photos. Again, we're going to use these as references, right? And we need to know how tall these walls are and how tall some of the other walls are as well. And whereas we only have a floor plan drawing, we don't have any elevations, how do we figure out the heights of these buildings? And one way to do that is to guess. In a professional practice, there's a lot of this guessing heights for existing buildings. Unless you've done an actual measure up on site and it's really important to get the existing building 100% correct, then you'll go to site with lasers and you'll figure that stuff out or you get it surveyed and get a professional to model up the existing building. In most cases, if you're just going to be demolishing it and you just need to show the demolition plan of what's existing, you can just model it up pretty roughly with some guesstimate heights. And that's what we're going to do here. Otherwise, what I could do is go knock on my old house's owner's door and ask them to measure up their building, and that probably won't go well. So what I could do actually is, if they haven't fixed it, I could break through that hobbit door and just snoop around their house and measure it up. I'm not going to do that. So one way to do this is to count bricks, right? We know that a brick is roughly 240 millimeters in height, I think. I better double check that because I can't remember. So they're 76 mils high. Most cases they're 90 mils. I'm going to treat this as 90 mils because it doesn't have to be perfect, and 90 mils is a lot easier to work with than 76. So each brick is 90 mils high. Now we can just count how many bricks there are. I'm going to go full screen here so I can actually see. We're going to zoom in. Okay, we've got 1, 2, 3, 4, 5, 6, 7, 8, 30, 31, 32, 33, 34. Okay, we've got 34 bricks. So if we go 34 times 90, 3,060. This, from that brick to that brick, this wall here, just over 3 meters. And then plus you've got this extra concrete plinth bit at the bottom. I'm going to say that's another 200, not maybe 300. So we're going to say 3,300 as the height of this first wall. So now we go back to Revit and we can put this height in for level 1 as 3,300. And so that's where the top of the wall for level 1 is going to be. That's this point up here. That's where the roof starts. What that's saying is that this point here is ground level. However, you can see that the site is actually on a descent. What would usually happen in professional practice, or maybe for your studio projects, you'll be given a survey drawing. What a survey drawing is the topography of your site, which has been surveyed out by a professional surveyor. In layman's terms, what this means is that a person has gone to the site and measured it with some cool tools to find out what the height differences are on the site. And so then the thing to note is that when you go into the entry, that's ground level. Then there will be stairs going up to this level here, which is level 1. And then there's some more stairs that go up to this extra piece of building here. So we've got the ground level, this part here, level 1, level 2. So ground floor is 0, and ground floor is actually here. That is 0. So then what's the difference between that and then level 1? And that is going to be difficult to figure out without elevations. But what we can do is we can see if there's any pictures of stairs, right? And you can see that this is the front entry. Maybe we can see if there's some stairs in here. Not those stairs. That can be helpful for later. Here, you can see that there's 1, 2, 3, 4, 5, 6, 7 steps going up to, this is up to level 2, the highest part of the building. And then I'm going to guess there's another 7 that go down to the ground level. And generally steps are about 200 millimeters high. That's the riser of a stair. So if we go 7 times 200, which is 1400, let's just make sure we do this right. So what I say, 7 by 200, that's 1400. That means there's a height difference of 1.4 meters. So in that sense, we're actually going to make level 1 1400. And then the level 1 roof is going to be 3300 above this point. So then we can create another level. Make sure you save your projects, by the way. I have not done this yet, and you should definitely take a minute to save it. So now we can create a level that is 3300 above that level there. And you can see there's a little guideline that gives you dimensions, and you can just go across there and you can see that it is 4700. You can place it anywhere and you can change it later. That's fine. But to make sure this is correct, let's go 1400 plus 3300. And that's 4700, which is correct. Now you can move this point out to snap onto one of these other points, and we're going to bring that one back as well. And now you can see there's a little lock there. That's locked all 3 of these together. So now if we want to move these dimensions for any reason, it's going to move all of them. That's just something to keep in mind. When you see this lock, you can click it to unlock it, and now it can move freely. But if you want to lock it to all 3 of them, you just press the lock button again. Now I'm going to move this one back over and snap that onto there. And we're going to call this, not level 2, we're going to call this level 1 roof. Would you like to rename the corresponding views? Yes. What does that mean? When you create a new level, what you're actually doing is creating a new floor plan. In this case, you can see that we've just created level 1, this floor level here, this level, and level 1 roof, which is that level we've just created. Now, if we double click on that, that is the roof plan, you could say, for level 1. On here, this is level 1 floor plan. Let's continue to create levels. Next up, we're going to find that the next level is another 1400 up, because that's 7 steps. 7 times 200, 1400 millimeters up from level 1. So that means the next level is going to be 1400 plus 1400, which is 2800. And I'm just going to place this anywhere and then click on that parameter there and type 2800. And now that says level 3. This is going to be level 2. Yes, we want to rename it so that it updates in here. You can see we've now got a level 2 floor plan, which is very handy. And we've now got our ground floor, level 1 level set up, level 2 level set up. We've got the level 1 roof. We know that's at 4700. If we go back to the start, we want to know the roof height up here, right? And we're also going to want to know, what's this carport height and some of these other things, which we can come back to. But for now, let's just get the levels for the floor plans and then also their roof heights so that we can extend some walls up. Up here, I'm going to assume it's probably the same height as this, but in our sense, we can count the bricks, and this is pretty low resolution, so it's going to be a bit hard. But you can kind of guess what each brick is. You can go 1, 2, 3, 4, 5, 6. I'm going to say about 34 again. And let's say that if it's not bricks, how do you find the height of a wall if it's not bricks? And in that sense, you kind of have to go off what's around it. We know about scale. This is why we put humans in our architectural drawings, because we know the scale of a human. If there's a person standing next to this wall and they're standing about here, you know that mark there is roughly 1.7 meters, because that's how tall someone is. In this sense, we know that a plant pot is probably about 600 mils tall, right? Well, this looks about 600 mils tall. So then you can kind of calculate, well, that's 600, that's 1200, that's 1800, that's 2400, that's 3000, and then 3400 just to add on to the top there. So that's how we can, use the surrounding context to figure out how tall this building actually is. So we're going to say it's 3400. So then again, we're going to go 2800, because this is level 2, 2800 plus 3400. And that's 6,200 millimeters. So we're going to create another level, and we're going to go, I can't remember what I said, 6,200. We're going to go from this side just to make it a bit easier. And we're going to snap it onto there. And you can see that that's got the 2 locks on it, so that now moves with it. We're going to click on here and we're going to type 6200. We're going to rename this to level 2 roof. We're going to rename the corresponding view. Now we've got ground floor, level 1, level 2, floor plans. Then we've got the roof plan for level 1 and 2. We need it for ground floor as well. Okay, so here we can see this is the other side of the house, but I know that the ground floor is down here. What we want to find out from this point to where pretty much the balcony sits. We know that from that point to that point was 3,400. We're going to assume again, probably around 3,400, but we can go count the bricks again. I can sort of see the color differences. And for the sake of keeping this simple, we're going to just use 3,400 again. So again, architecture tab, click level under the datum section, and we're going to click from one side to the other. Doesn't matter where you place it. We're going to rename this to ground floor roof. Rename it. I'm going to make this 3,400. In the next lesson, we'll be learning about type properties and materials in Revit so that we can begin modeling in the floors of our building. If you'd like to get access to all of the course files, materials, and resources, as well as 4 hours of ad-free content, you can feel free to head over to my website and check out the course. I'll see you there.